if we have about 21 different emphasis areas, programs, if you will, within the regional board. Those are on the minds. Those are on the slide. Those that show up in purple are the ones that I'll be talking about either directly or indirectly today. So like number 3, I won't be talking about the cannabis program. It's an interesting program, it has its own issues. I won't be talking about the mining program, although maybe I should, because we have some real engineering problems with it from the standpoint of abandoned mines, how you treat that water, the impact that they have on the environment and so forth. So without any further ado, I'll get on. The Central Valley itself, we talk about the hydrologic boundaries of the valley, and they extend all the way up to the Oregon border. There's Goose Lake up here, and periodically when it spills, it runs into the Pitt River, which is the tributary of the Sac. And the boundaries continue along all the way down here to Tehachapi. And it's, I forget the number, I think it's, we cover all or parts of 32 counties in California, 40% of the state's land area, 75% of the state's irrigated agriculture, about 7 million acres. I'm not going to be talking to you today about land retirement programs that may come about because of the groundwater programs that are being put in place, SGMA, State Groundwater Management Program. But in that program, there's some talk about retiring maybe up to 2 million acres. 2 million out of 7 million is an awful lot. That does have an impact on water quality also. Might point out that 40% of the state's population drinks groundwater, and the Central Valley does supply water primarily from its surface water supplies to a good part of the state. In fact, water is supplied all the way down to San Diego area, and water is supplied out into the Mojave Desert. So there's a huge plumbing system in the state that moves this water. There's water quality issues attendant with this. One of the things that really is important on the water quality side are the water quality permit systems that are in place to really address the quality of the water that is released to the land and to surface waters. For wastewater discharges to surface waters, the National Pollution Discharge Elimination System, otherwise known as the NPDES permit system, is mandated by the Water Quality Control Act, which was passed in 1972, I believe, by the Congress. And waste discharge requirements are for discharges primarily to land, and those are mandated in the Porter Cologne Act of the state of California. As can be expected, the state of California's water quality statutes are much stricter than what you find in the federal. The federal focuses on surface waters. It does not touch the issue of groundwaters. Of course, the NPDES program, as I mentioned, is surface water discharges. The pictures you see are examples of some of the plants and some of the discharges that we are involved with. Because of COVID impacts everything, and COVID has increased our backlog. And the backlog is, but we are maintaining what is required for us. Permits are supposed to be renewed every 5 years, and every 3 years. and the waste discharge requirements every 5 years. We are 76% compliant, meeting EPA requirements. We are also in the process of implementing a program that would allow for the results that are reported to us from monitoring to have a much stricter level of reliability, of accuracy. One of our programs, the Irrigated Lands Program, went into place in the early part of the 2000s. And pictures you see are some examples of the Irrigated Lands Program. Issues we have is water quality issues from this are many, but the biggest and the most prominent have to do with salt and with nitrates. The salts are imported. We get about nominally 2 million tons of salt from delivered surface waters. And the water coming out of Shasta and the other dams in Northern California are very high quality. But those waters go through the delta, and they're picked up in the south end of the delta. And there is considerable tidal intrusion into the delta, which is imports salts into the delta. And that's where the large amount of the salts come from. Then they are discharged into lands in the San Joaquin Valley. When we don't have surface water deliveries, as during times of drought, we have lands that are either fallowed or they are irrigated by increasingly more saline groundwaters, and that creates its own set of issues. Of course, the nitrate problem comes up partly from use of wastewater for irrigation from septic tanks, but a large amount of it comes from from the use of fertilizers on crops that are grown primarily through irrigated agriculture. And how to address that problem becomes a real issue. That issue, by the way, some research being conducted on this campus is looking at the use of a very novel pretreatment system using ion exchange, both anion and cation resins. And then we have a proposal in to extend this work would be using a two-phase RO system whereby we can separate sodium and potassium. And what we would be doing is regenerating the ion exchange resins with a potassium salt rather than a sodium salt. And many of the crops are potassium deficient. So if we can use a discharge stream which is rich in potassium and removing the sodium from the discharge that would go back to the soil, we can in fact create a product which is very beneficial to particularly to many tree crops, but to other crops too, such as cauliflower, tomatoes, and so forth. That research is part of that research is being funded now, and we're applying for other funding to continue that research. We think it has a very good future. What it does is it reduces the salt load. So getting back to the Irrigated Lands Program, the first conditional waiver on that occurred in 2003. We were focused only on surface water. The conditional waiver was renewed. And then in 2012, we put out a general waste discharge requirements. And it included both surface and groundwater. So it's a comprehensive program at this point. Now, the difference between a conventional waste discharge requirement, which goes to an individual, and that individual can be a person or it might be a business, and a general waste discharge, a general order, so to speak, is that the general order applies to the area for which it's designated and for the type of discharge for which it's designated. And it's incumbent upon the discharger to apply and be part of that system. It's a lot more efficient way to operate discharge requirements. And as an example, a stormwater program also operates through a general order. And the city of Fresno, as an example, has applied and is part of that general order for stormwater discharges. But the general order is in place, and it is continuing to develop over time. It was carried out as a very transparent process and over a long period, 17 years. Very comprehensive CEQA effort. CEQA, California Environmental Quality Act, is an important part, and you don't learn much about it when you're becoming a civil engineer, but when you go to become part of the practicing community of civil engineers, quite likely in California, you're going to run into CEQA. And of course, one of the things that we attempt to do as we go through this, and our stakeholders hold our feet to the fire on this, is that we don't do monitoring for the sake of doing monitoring. The monitoring has to be serve a real value. We have to find ways that we can do it that are most cost effective. For that reason, well, we'll get into the monitoring bit. ILRP stakeholders are quite varied. We have a number of coalitions. I'll talk about the coalitions in a minute, but a number of other organizations participate. And you can see here by their logos who they are, but certainly they represent a spectrum of interest insofar as the Irrigated Lands Program is concerned. We have 9 general ILRPs, starting from the north Sacramento River area and going south. That actually represents 14 different coalitions. There are 8 coalitions down here in the Tulare Lake Basin area. There is one of those coalitions, the remaining 5, is the Rice Coalition, and it's a commodity-based coalition as opposed to being a geographical-based coalition. But the 14 coalitions have members, and those members, they represent their members to the regional board insofar as the general orders are concerned, which drive the ILRP. Water quality really means that there's a lot of third-party assessments, both on groundwater quality, sediment discharge, and erosion. Those are things that we're very concerned about. Water quality monument, you can read the list better than I can. The growers themselves are required to turn out a number of reports. The nitrogen management report is focused very much on fertilizer use. Third-party management plans have to be put together for surface water quality and groundwater quality as applicable. And the growers must implement practice consistent with those plans, meet performance standards. And the grower plans naturally have to contain nitrogen management and sediment and erosion control. We're attempting to keep nitrate out of the groundwater as much as possible, but obviously you're going to have some leakage to the groundwater. There's ongoing commitment by the coalitions to present learning workshops, various other activities that keep their growers on top of the best practices to maintain water quality. And some of these practices, believe it or not, even help them do a better job. Moving down, a couple of success stories where we go on. The San Joaquin River was listed as impaired by Diazinon in 1992. We talk about it being impaired. We're required to evaluate each river for its water quality. If it fails on water quality in any for any contaminant, then it has to be put on a federal list known as the 301D list. And Diazinon exceeded water quality standards in the river and was put on that list in 1992. The ILRPs required, and you can see the Diazinon being put out here for on trees for pest control. The ILRP required practices to improve water quality, and the Diazinon was delisted for the San Joaquin more recently. You can see we were getting hits up through 2010, and finally in 2011 we came into compliance. Truly a success story. We've remained in compliance on the Diazinon. Another one was in the rice program. I talked about this was a commodity program, primarily up north of Sacramento, but there is a small amount of rice grown below Sacramento. From their releases from their stored water, there were significant fish kills. There was contamination of drinking water, particularly for taste. Sacramento folks could have told you about that. And another success story is the Grasslands Bypass, where we have a significant problem. The Grassland Bypass area is south of Los Banos on the west side. And in that area is a significant fan of that was created by storm water carrying sediment out of the Coast Range, and that erodes material over thousands and thousands of years, contains a large amount of selenate. Selenate is deposited there maybe 7 million years ago by volcanic activity. Selenate is a first cousin to sulfate. Both of them are very water soluble. The selenate, every time you get a storm, it dissolves selenium in the soil, carries it with it. Likewise, when you irrigate the land, that selenium load is shoved downward into the groundwater. There's been a 95% reduction in the selenium load that's discharged. That finds its way typically to the San Joaquin River. And this is through activities ongoing to this day, and will have to get for indefinite future. Though there is significant work underway to find treatment for that. There was a treatment plant, reverse osmosis plant, put in place some years ago by Bureau of Reclamation. That plant will be coming back up. It's a research facility. It's not big enough to treat the whole load they have there, but it's a reduced salt and selenium. And in the long term, that becomes a huge issue for us for a long number of years. Current groundwater program, nitrogen management program, nitrogen management programs are a big part of that. There's also trend monitoring. We have management plans that have to be done, and so I can stay within time. I'm just going to start going a little faster. We have drinking water monitoring. All domestic wells have to be surveyed, and users have to be, that are using the groundwater, have to be notified of the quality of the groundwater they're using. So Surface water program, all of these things, sediment erosion control are important parts of that. We have monitoring sites for those. And I'll go through this quickly because we got a long ways to go. Management strategy is based around core sites. And the core sites are at very, very critical points for water quality monitoring. We have representative monitoring sites, and a representative site is a site that's chosen because it's representative by soil, by source water quality, by the type of agriculture that's taking place, to other areas within the particular coalition area. And through that is one of the ways that we, with a high level of confidence, can decrease the amount of monitoring we have to do. In other words, not every farmer or dairyman has to put in a monitoring site for both surface water and groundwater if we have if they are a member of the coalition paying into the maintenance of these systems. And so gives you a better idea of what, now how do I go on? There we go. So this gives you some idea in the valley and of the number of this shows you median concentration for nitrate, and this here is for salinity. And the areas where we really have problem are in the San Joaquin Valley, particularly in this part of the San Joaquin Valley. And for salinity on the west side of the valley tends to be where some of the bigger problems are located. Which leads me to the CV salts program. I already talked about how much salt we're importing. If we're bringing in anywhere from maybe 2 to 10 million tons of salt a year, we got to find a way to move it out. Some of that comes from the water that we're bringing into the valley, but we also bring it in terms of fertilizer. 600,000 tons nominally example of calcium sulfate each year is used on the soil to allow the water itself to better leach through the soil. And to do that, and to do it so that it's economical, and that so that we can mitigate its long-term impacts on agriculture. We've seen as soil becomes salted up in this valley, we've seen it, the type of crops that can be grown in particular areas being less and less. And to be able to mitigate that, we have to find a way over time to mitigate salt. This is a better picture of the nitrate issue that I presented to you. Here's Fresno and Sacramento. There's hot spots you can see even up above Sacramento in certain areas. And these hot spots also have to be addressed. But the compliance strategies that we have for beginning in 2006, because this is when we kicked off the CV salts effort. CV salts, Central Valley, salinative alternatives for long-term sustainability. There's always the no action alternative. And if we take that, we will over time see the valley salt up. So let me go back. I got so excited. Going through this pretty quickly. There we go. We have the alternatives down below here. This means that we have to develop a basin plan. Basin plans are required by the federal legislation. And those basin plans do contain all of these aspects, but they allow you to, over time, to protect your water, both your groundwater and your surface water, and to give you sustainability. The cost is the big issue. The cost is always the big issue. So one of the solutions is in-valley. And a in-valley solution means that you're doing these kinds of things. You're managing fertilizers, you're managing ponds and making sure that they're not impacting groundwater or surface waters even. Municipal source controls, the best quality water possible for municipal use. You're restricting landscape irrigation. You are really looking at your industries to try to pull down the salt load they're contributing. That's a big issue. Their water treatment plant has to keep track of how much salt they're discharging. You have industries that discharge an awful lot of salt, particularly within food processing industries. In the industrial sectors, there's ways to go, such as deep well injection, mechanical evaporation, landfill disposal, etc. We can do out of valley discharge. That's a pipeline to take it out of the valley for direct ocean disposal. And the last time that was came up, brought forth by Bureau of Reclamation in the early 2000s, it really created a political backlash by folks that lived on the coastal areas. They said that the valley Central Valley wanted to discharge their poisons out of the valley. That's not out of the question at this point, not discharging our poisons, but discharging our salt. But if we are to discharge our salt, that will have to undoubtedly be treated so that the chemistry of that water matches the chemistry of the water it's going into. In other words, it's going to have to be primarily a sodium chloride stream. And quite likely what we're going to come up with over time, and that's what the CV salts effort is all about, is a combination of both. There may be some movement of salt out of the valley by pipeline. There will have to be tremendous efforts within the valley to manage salt locally. One of those is, if you're recovering salt, is what kind of materials can you make from that salt? Can it be made into a road material, as an example? Some of the efforts that have been looking at this will take the salt and will make a number of products, such as strong bases, strong acids, various types of commercial salts. A good example of the latter would be sodium bicarbonate. And sodium bicarb is used extensively for making glass. By the way, we have a fairly large glass industry in this valley to take care of the wine industry. So there are, when you get down into the nitty-gritty and look at it, a lot of things that you can do. The question is, how can you do it and stay in business? In other words, how can you do it and still have a reasonable profit? I mentioned the basin plan amendments had to be developed. 2018, that happened, addressing both groundwater and surface water. They use a management zone concept where you have a lot of uses similar in a particular area. Those people within that management zone are responsible for developing plans. Focus right now is on nitrate control, and a lot of notice to comply letters have gone out in that respect. Moving on to the Oilfield Program, in the southern part of the valley, extending across from over to the Kalinga area on the west side of the valley is a quite large oil production, large amount of oil production. We're one of the larger areas in the United States. All kinds of things go on over there. Some of this water is used for irrigation, about 40,000 acre feet a year, maybe more. There has been a huge issue on, well, how much of that, of those chemicals that are being used for fracking or for well maintenance are getting into the food itself that's being produced. And because of that, about 3 years ago, a group was put together to look at that question. A white paper will be in front of the regional board at its February meeting. A lot of work has been done, but I can tell you right now that we find that you don't have to be worried about fruit that you're eating from those areas. The bigger issue is not the organics, as it turns out. The bigger issue when you're dealing with with plants are the inorganics. And in fact, we had one of our samples, which happened to be a control sample, showed an excessive limit of nickel. Turns out that soil there had excessive limits of nickel. This is the one of the other things that happens that from time to time in the oil field. You have very interesting spills, if you will. This was from a line that broke. As we supply hot water is supplied. You can see the hot water lines all over the field, simply to be injected into down the well to lower the viscosity of the crude so it can be pumped to the surface. Along with that go a lot of materials to control corrosion, and some materials to also impact the viscosity to give us a material that can be pumped. The Forest Activities Program, we have large fires, and the creek fire, by the way, is only 70% contained. It's not growing much, I guess, if at all, these last few days, but since we had some precipitation, but they're hoping to wrap it up soon. But what happens with the fires? Well, in the forest area, our overall forest management plan has road control, road management, so that you don't get eroded roads. And with the fires, one of the things we have are mudslides. A tremendous amount of erosion can take place if you don't get in there early and start mitigating by certainly the spring getting a lot of plants in there, but in the meantime, a lot of bad things can happen. You have to put in new roadways in a lot of areas so that you can move back and forth. A lot of engineering goes into this. Last program I'll talk about is the Confined Animals Program. Poultry, they have waste, and the wastes themselves have to be treated in one way or another. There's a lot of work going on with the dairy industry to take their manure and create methane from it. So you get you have an energy source. If you're using fuel cells, as they are experimenting with in some areas, you can actually create hydrogen. You can have hydrogen fueling stations and those kinds of things you can run your trucks off of. But waste management is a huge issue here. A lot of engineering, innovative engineering, needs to take place to manage that. So one last thing. I mentioned ponds. In the Confined Animals Program, orders, because they use ponds of this nature, these ponds have an impact on groundwater. And in fact, some of the old ponds were excavated down to groundwater, particularly on the east side where you had shallower groundwater. And, you know, we've got to stop those discharges from those ponds. So thank you very much. I covered a lot of material, probably too quickly.
Thank you so much, Dr. Longley. We have one question in the chat that says, how does ILRP work considering sigma?
You asked a good question. I'm trying to find the picture that wanted to come up all the time before. No, I went the wrong way. I showed a picture earlier of management zones, and the management zones are going to have that task. These management zones serve the same people that Sigma serves. And one of the issues that, and I can't answer your question precisely. All I can tell you that if I'm a farmer out here, and knowing that there is a requirement under Sigma to conform to protect water quality, and knowing that the ILRP has that responsibility also under this local management zone, local river management zone, we are very interested in how we can marry those two efforts. And that effort is still underway, but they have to be married to be successful. But I can tell you, having worked with these stakeholders over a long period of time, that they're not going to pay twice for the same thing. And so there will be a wedding of the two programs one way or another. It's not a direct answer, but it's one that is that was a crucial question.
Okay, and our next question, is there any insight into how the selenium issue is being addressed?
Yes, there is. There's some very interesting work that's been carried out that really shows that we can treat the water through a very novel process and end up with a residue rich in selenium. That's of interest because normally the normal approach is to treat this and discharge it into a hazardous waste management facility where you have to manage it to the end of time. However, selenium, large quantities of selenium are used in the electronics industry. The problem is we have a federal law which prohibits us taking a waste management stream and moving it into the resource stream. And so we're starting to work on how do we do that. It's going to take, that's a political issue. It's going to take a change in how we think about managing waste. But it's going to have to happen if long term if we're going to make this successful. I could say the same thing about arsenic. We have a large amount of arsenic in some areas of the Central Valley. It too, well, to give you an example, the city of Coalinga treats its water to remove arsenic. It goes to a waste management site where it's, once again, managed to the end of time. We do not mine any arsenic in the United States. Arsenic is mined elsewhere in the world, and we import into the United States a significant amount of arsenic each year, which once again is used in the electronics industry. There's a disconnect here, a disconnect which needs to be addressed.
Thank you, Dr. Longley. Are there any other questions? Okay, I'll give you guys a couple more minutes to add those in there in the Q&A box. Dr. Longley, what is the most interesting project that you've worked on with regards to this?
Well, probably the most interesting one is the one we're working on now that I described to you, whereby we can take a what was nominally before a waste material, and by changing the process and changing that material, we actually come up with a material which can be used for fertigation. Has a useful value. We still have a waste stream, but we reduce the volume of that waste stream significantly.
Yes, absolutely. That's used in wastewater treatment a bit, and I think that's one of the most amazing parts. We have one more question. It says, TDS indicates what?
Oh, I'm sorry. Total dissolved solids. And that's how we measure salt, if you will, because it's not just sodium chloride, it's calcium chloride, calcium sulfate, sodium sulfate, the list goes on and on. But basically the anions being sodium and calcium, the cations being the bicarbs, the cations being sodium and calcium, but the anions being bicarb, carbonate, the chlorides, sulfates, and so forth. Those are the major part of your TDS, or total dissolved solids.
Awesome. Mike Mayfield wanted to say thank you for the fascinating talk, and he also wanted to ask about the proposition you raised on the following 2 million acres. Could you please elaborate on this and share some insight as to how this might play out in years to come?
Well, first of all, I don't think we're going to retire 2 million acres, but that's a number that I read in the newspaper. I guess you'd have to go to Fresno B for the source. Some folks have suggested that sigma, and sigma is not something that I can claim to be an expert in. Stephanie's mentor, Sarge Green, would be the person to talk to about that. But some folks have said that there's going to be a lot of land retired. I think that we'll be innovative and ingenious enough that we'll find ways to get better use out of our water. We find, in fact, that you can grow crops using less water by using other technologies, but it requires aquaculture as an example, but it requires a much larger investment in the infrastructure to grow those crops. It becomes an economic issue. Can you grow crops and market them and get an economic return, reasonable economic return on those crops? So that's a question that I really can't answer to any degree of accuracy, only that to say that it begs for a lot of good engineering, a lot of good science to find ways to better use our water. And let me add that world population is growing. There's going to be even a greater demand in the future for our ag products. So even if we keep using the same amount of water we have today, how can we use it more efficiently to get more bang for the buck, so to speak, in growing crops?
Fantastic. And I apologize if I pronounce this name wrong, but Kayleani says thank you very much for the informative talk and that she enjoyed it. And she asked how she could approach you if she has any ideas, if you have an email or any contact information that she could talk to you from.
My email would be karll@mail.fresnostate.edu. My gosh, I guess you just put my name in and put Fresno State, and you'll find my email address.
Perfect. And Fang Teeter asked, do any of the programs you've talked about also monitor subsidence, or would this be monitored under Sigma?
No, we're focused on water quality, and subsidence is more under, excuse me, Department of Water Resources. to the best of my knowledge. But certainly subsides impacts water quality.
I believe that is all. So thank you so much, Dr. Longley. We really enjoyed your talk, and we hope you have a great day.